Alright, so if I give you the function f of x, I'll give you a rational function, 2x plus 3 over x minus 1. To find the inverse algebraically, you're just changing the f of x to y, something you can work with. Then you're replacing every x value with the y values, and every y value with the x. To get rid of the denominator of y minus 1, you're multiplying on both sides by y minus 1. This side will cancel. You're left with 2y plus 3. Over here you need to distribute. Get the y's together to the side, move the constant to the left side. Negative x minus 3 equals 2y minus yx. Greatest common factor, factor out a y. Then you're going to divide both sides by 2 minus x. And then over here, that negative sign comes out in front, in line with your fraction line, and you're left with y equals, or the inverse of x, equals the opposite of x minus 3 over 2 minus x. Okay. So, let me go and put that on here. And now we're going to graph them. I graphed in the middle box because I wanted more space. So let's go ahead and make a graph for this one here. This will be my blue, and this will be my green. Alright, to find a vertical asymptote, what do I have to do, class? I'm going to set the denominator not equal to 0. So x minus 1 is not equal to 0, so you have x equals not equal to 1. Raise your hand if you got that. So write that down. That's how you find a vertical asymptote. Let's go ahead and graph that. So when you see a fraction, rational function, you're going to set it not equal to 0. Okay? To find a horizontal asymptote, I'm just going to look at their powers, right? So this has a power of 1, and this has a power of 1. So 1 is equal to 1. Yes? When they're equal, you need to reduce 2x over x. The x's will cancel, and you're left with y equals 2. Raise your hand if you got that one. Good. So there's a quick review of how to graph. So let's go ahead and do that. Horizontal asymptote at y equals 2. And let's just say you're stuck in a bind, you don't have your calculator. So how are you going to graph this? Well, one thing you can do is you just pick a number. So I don't have my calculator. I'm going to show you guys how to graph this. We'll verify with our calculators. Just pick a number, your x value is somewhere over here. For example, let's pick -3. And I want to know at x equals -3, is it above the pink line or below? Does that make sense? And then it'll tell me where my graph is. So I can come up here. Class, what's 2 times -3? -6 plus 3. So numerator is -3. And -3 minus 1. -3 divided by -4 is positive 3/4. So at -3, I'm going to have a positive 3/4. Does that make sense? It's actually below the pink line. Let's double check that. Take your calculator. Plug it in there. And I'll graph it. And you can see that, right? Let's graph it. Class, what's the domain of this graph? I'm coming from the left side, right? So these are negative numbers. If you want, you can put in your graph negative infinity, right? What number can it not be?
1.
Positive 1, right? That's my vertical asymptote. And then going this direction, I can't pick, don't include 1 to infinity. And then my range. Negative infinity, don't include 2. So this is a fancy way of basically saying pick all numbers, negative to positive, and don't include 1. Let's do the same thing for our inverse. Vertical asymptote. Do you have one? X is equal to 2. Go ahead and graph it. Class, what's our horizontal asymptote?
1.
Remember, we took that negative sign from the numerator. Do you see that? We took it from right here. What does that mean? So I have a negative x and a negative x. Do you see that? So when your exponents are equal, you reduce, and I have negative x over negative x, so y is equal to, when you reduce that, what do you get? You get a 1. I should give you guys a quiz with no graphing calculator. Let's pick a positive number. Let's pick positive 4 and see what happens. Let's see where my graph ends up. 4 minus 3? 2 minus 4? 1 divided by negative 2? And opposite of negative 1/2. So when I graphed it, I got 4 and 1/2. So I'm going to be, my graph's probably going to look like something like this. Notice how it kind of looks like a baseball, a line with two, or a stick person maybe. Do you guys see it? Arms and legs. Do you guys see that? And what happens is that person kind of just switched places. Let's do the domain and range. Class, what's my domain? Negative infinity to what? 2 to?
Positive infinity.
Tell me what to write for the range.
Negative infinity to 1.
To 1.
1 to positive infinity.
Do you guys see what happens to the domain?
Yeah.
They switch. Do you see it? For the ones with words, we'll probably skip that one. Probably take us a lot of steps to prove that. So this is how you take the function f of x. This is what its graph looks like. But if you take the inverse, you'll see how they're related by switching in their domain and the ranges, and you can see how the graphs you can take in inverse.